Okay, this video is on average rate of change, and the average rate of change is the slope of the line that goes through 2 points on a curve. This line is called a secant line. So right here in green is a curve, and we want to get the slope of the line that goes through 2 points on this curve. Well, the slope formula is you find the difference in the y's, and you divide that by the difference in the x's. Y's over x's, okay? Well, to get the slope of this secant line, we just get the y value at this x value and the y value at this x value and subtract these two y values. And write them in function notation, we say f of x2 minus f of x1. That means the y value at x2 minus the y value at x1, and then we take the two x's and subtract them. So it's really just the slope formula, and you're finding the slope of the secant line, the line that goes through those 2 points. So let's do an example here. This says find the average rate of change of the function f of x equals x squared from 3 to 5. Okay, so here's my x values, 3 and 5. To get my y values, I just substitute those into the function. So here's what I calculate. So let's get f of 5. So putting 5 into the x squared, we get 25. And putting 3 in for x squared, or putting 3 in for x right here, we get 9. And then we just subtract the y values, 25 minus 9, right here, 25 minus 9, and divide that by the difference in the x values, 5 minus 3. Okay? And if you take 25 minus 9, you get 16. 5 minus 3 is 2, and 16 divided by 2 is 8. Okay, let's do another one here. It says find the average rate of change for the same function going from 3 to 4 this time. Well, if you put in 4, you get 16. 4 squared is 16. Put in 3. 3 squared is 9. So it's just 16 minus 9 over 4 minus 3. And that would give you 7. And the question here is, how could we get a better approximation for the slope of the tangent line of the curve at x equals 3? Well, see here at the top, this one, we did the slope of the secant line from 3 to 5. From 3 out to 5. Then we did from 3 to 4. So if you want to get the slope of the tangent line is the curve the line that hits the curve in only one point. Well, the closer the 2 points should be together. So if you want to get the slope of the tangent line, then use 2 points that are extremely close together, like 3 and 3.01. So the closer the points are together, the closer the slope of the secant line will be to the slope of the tangent line at that point. Well, anyway, here's another example. A person drops a ball off a 400-foot cliff. What is the equation of the height of the ball in terms of time? Okay, well, remember this from section 1.3, that the height of the ball can be calculated using this function here. H of t is equal to negative 16t squared plus v sub naught t plus h sub naught. V sub naught is the initial velocity. H sub naught is the initial height. And your h of t tells you your height at any given time. When we did this back in section 1.3, we weren't using function notation. We just said capital H here for height. But h of t is your height at any given time. So on this one, the person drops the ball, okay? Drops the ball. So the initial velocity is 0. He didn't throw it up or throw it down. It just drops the ball. So the initial velocity is 0. The initial height was 400 feet high, and the 16 stays in there due to gravity. So we have this equation, h of t, or this function, h of t equals negative 16t squared plus 400. Now what they want us to do with this is find the average rate of change in the height of the ball from 2 to 5 seconds. Well, that's back to what we were doing a little bit ago. Put the 5 into the function, and if I put 5 into the function here, 5 squared, see here's the function, just put 5 in there. So it would be negative 16 times 5 squared plus 400. And if you work that out, you get 0. Okay? And then put the 2 in, because that's the other time value, the other x value, or in this case t value. If I put 2 in for t, you get negative 16 times 2 squared plus 400, which is 336. So there's my two y values. Here's my two x values. And then just work it out here. So it's going to be 0 minus 336 over 5 minus 2. And again, where that came from was, see, here's what I got when I substituted 5 in. I got 0. So make sure they line up above each other The 0 is the y value we got when we put 5 in. So the 0 is the y value and 5 is the x value. And when we put 2 in, we got 336. So 336 is the y value, 2 is the x value. So it's just a change in y's over a change in x's. And if you work that out, you get negative 112. And what does the solution mean? Well, the change in distance over time is velocity, how fast it's going. So the answer of negative 112 up here means that the average velocity of the ball from 2 to 5 seconds was 112 feet per second. The negative in front of that just means that the ball was falling. It was going down. That's what the negative means. So that's the average speed of that ball, about 112 feet per second right there. In 4C here, it says use this same equation to find the average rate of change in the height of the ball from 2 to 4 seconds. Okay. Put in 4, we get 144. Okay, I put that into the function, and I get 144. Put 2 into the function, and I get 336. So then just use your change in y's over change in x's. 144, see that one, minus the 336 over the x values that you substituted in, 4 minus 2. If you work that out, you get a negative 96. So that means the average speed of this ball from 4 to 2 seconds was, from 2 to 4 seconds was 96 feet per second, and the negative just means it's falling. So it's actually the average rate of speed was faster when you got the average speed from 2 to 5 seconds compared to 2 to 4 seconds. The reason is the longer this thing's falling, the faster it's going. And in 5 seconds, it's going faster than what it was going at 4 seconds. So that increased your average speed right there. Now you can do these on Excel too. Let's go ahead and show you where you can do these. Here's the first one. On the first one up here where the function was x squared, you just go to the quadratic sheet. So let me do that. So on the quadratic sheet, this function was just x squared, so the a is 1, and the b and c are 0. So you have those in there. So that's the graph of y equals x squared. And we got our coefficients in, and then on that problem, it said to get the average rate of change from how many to how many seconds? 3 to 5 seconds. So watch. All we need to do is we could put in 3 here and 5 here, and there's my x values, and here automatically are my calculated y values. And then just in any cell you're not using, we could calculate. I'm going to do equals, parentheses, take my y values and subtract them. Just do click minus click divided by parentheses the x values. Click minus click, close parentheses, and there you go, 8. And let's check it out here. And we get the average speed here, or the average rate of change was 8, and that's what we got. And the same thing on down here when we did the average velocity from on this projectile motion problem right here. Let's put in those coefficients, negative 16, 0, because there's no t, and then a 400, negative 16, 0, 400. So to do that one, negative 16, 0, 400, and it wanted the average rate of change on what x values? Well, let's see, from 2 to 5 seconds, right here, from 2 to 5 seconds. Well, let's check it out. So all you need to do is here, 2 to 5, and automatically, since the formula is already in here, we got it made. And you can see the formula is up in this area right up here. Or if I double click, you can see the formula. And again, I got this formula by typing equals, parentheses, clicking on the y values and subtracting them, then divided by parentheses, clicking on the x values and subtracting them. And whatever order you subtract these, you got to subtract these in the same way. I did this one minus this one over this one minus this one. So the answer to that is negative 112. And that's actually what we got when we worked this problem out, pencil and paper here too. And that's how you get your average rate of change.